The leaves of a touch-me-not plant get closed when someone touches them. Similarly, let us learn about an instrument whose leaves converge or diverge depending on the nature of the charge on a material. In our previous section, we have studied the pith ball electroscope. Now let us understand the working of the second type of electroscope, that is, gold leaf electroscope. It consists of a vertical conducting metal rod to which a brass ball is fixed at the upper end, and a pair of rectangular pieces of gold foil is attached to the lower end. These are called the gold leaves. The electroscope is known as the gold leaf electroscope. This arrangement is placed inside a glass jar to prevent any disturbance due to air. An insulating material like cork is fitted on the mouth of the glass vessel to hold the metal rod in its place. Now let us see how this electroscope can be charged. Initially, when the electroscope is in the neutral condition, the gold leaves hang vertically downwards due to gravity. Take a glass rod and rub it with a silk cloth. The rod becomes positively charged. This charged rod can be used to charge the electroscope by two methods: charging by conduction and charging by induction. In the case of charging by conduction, a positively charged glass rod is brought in contact with the metal ball on the top. The free electrons of the electroscope get attracted towards the positively charged rod and enter the rod. Thus, the electroscope acquires an overall positive charge which spreads over the entire electroscope. Since like charges repel, both the positively charged gold leaves repel each other and move apart. Thus, the electroscope gets positively charged. Next, if either a perspex or an ebonite rod is rubbed with fur, the rod becomes negatively charged. Bring it in contact with the neutral electroscope. You can see that both the gold leaves repel each other and move apart. This is because the negative charges of the rod repel the free electrons of the electroscope. The positive charges which are near the rod get neutralized by the negative charges of the rod. The negative charge spreads over the entire electroscope and the gold leaves repel each other. Thus, the electroscope gets negatively charged. In the case of charging by conduction, a positively charged glass rod makes the electroscope positively charged, and a negatively charged ebonite rod makes the electroscope negatively charged. Thus, both the electroscopes receive the same charge as that possessed by the charging body. The electroscope can also be charged by placing the rod near the electroscope but not touching it. This is called charging by induction. Take a negatively charged ebonite rod and bring it near a neutral electroscope. But do not bring the rod in contact with the electroscope. The negatively charged rod repels the electrons within the electroscope, which move towards the gold leaves. Thus, a positive charge is induced on the ball and a negative charge is induced on the leaves. Hence, the leaves repel each other and move apart. Now touch the ball with your finger so that it gets grounded. The free electrons of the electroscope flow through the finger to the ground and leave each other and collapse. When you remove your finger, the earthing is removed, but still the leaves remain collapsed. Lastly, when we remove the ebonite rod from the vicinity of the electroscope, the positive charge gets distributed all over the electroscope. The leaves repel each other and get diverged. Thus, the electroscope becomes positively charged. Next, bring a positively charged glass rod near a neutral electroscope so that the rod does not touch the electroscope. The free electrons of the electroscope are attracted towards the positively charged rod and the positive charges are repelled. Both the leaves acquire a positive charge and each other. Now, without removing the positively charged glass rod, touch the electroscope with your finger, thereby earthing it. The free electrons from the ground are attracted towards the positive charges of the electroscope. The positive charges of the electroscope combine with the negative charges and neutralize them, because of which the leaves collapse. Now remove the earthing without removing the positively charged glass rod. Thus, there is an excess of negative charge in the electroscope. Finally, on removing the glass rod, the negative charge gets evenly distributed to the leaves. Hence, the leaves once again repel each other and move apart, and the electroscope is said to be negatively charged. This is called charging by induction. Such a charge electroscope can be used to determine whether a particular body is positively or negatively charged. Take a positively charged electroscope. The diverged gold leaves indicate the presence of a charge on the electroscope. The type of charge on a body can be determined either by conduction or by induction. Take any charged body and bring it in contact with this electroscope. If the leaves get further diverged, then we can say that the charge on the body is positive or the body is positively charged. But if the divergence decreases, then the concerned body is negatively charged. To find the charge on this body, replace this electroscope with a negatively charged electroscope. Its leaves are diverged, indicating the presence of the charge. Touch the body to this electroscope. If the leaves show no change in divergence, then the body does not have any charge or is neutral. But if the leaves show further divergence, the body can be identified as having a negative charge. The charge on the body can also be identified by the method of induction. If a positively charged body is brought near a positively charged electroscope, then the leaves show further divergence. But if a negatively charged body is brought near a positively charged electroscope, then the divergence of the leaves decreases. Hence, when any charged body is brought near a charged electroscope and the divergence of leaves increases, then the body has the same charge as that of the electroscope. On the other hand, if the divergence of the leaves decreases, then the body has a charge opposite to that of the electroscope. To summarize, an electroscope is a charge detecting device which detects the presence of even weak electric charges and determines whether they are positive or negative. To detect the charge on a body, an electroscope has to be charged. The charging of a gold leaf electroscope can be done by two methods, conduction and induction. In both the methods, a previously charged body is used to charge the electroscope. Once the electroscope is charged, it can be used to detect the charge on any body, again by two methods, that is, by conduction and induction. In both the methods, on the basis of the behavior of gold leaves, we can detect the presence and the type of the charge on any body. We have learnt the different methods of charging an object and detecting charges on an object. We will now visualize the origin of charge in detail and the basic properties of electric charge. Stay tuned.